In this video, I will discuss about the normal approximation to the binomial distribution and also the Poisson distribution. So here are the 4.4 summary of it. Now, binomial distribution will have X, a binomial with a parameter n and p, where n is number of trial and p is your probability of success. And normal is X having a normal with mu and sigma square, where your parameter is mu and sigma, your standard deviation. So, when is it the binomial distribution can use a normal approximation? When NP is greater than 5, means that your n multiplied by p will be greater than 5, and your p is from 0.1 until 0.9, alright, which is inclusive. For normal approximation, you need mu, which is the mean, equivalent to n multiplied by p, and your sigma is square root of npq. Now, madam, sometimes you ask, when is it that your p is less than 0.1? How can we use the approximation? Whether can use normal? No, there is another approximation, which if you still remember, when n greater than 30 and your p is less than 0.1, sorry, I got it wrong. It's not n greater than 30. It should be n greater than 50, which is n is large and your p is very small, which is less than 0.1. Then you can use the Poisson approximation with your lambda is np. Okay? Now, the second one, let's look at when your Poisson distribution and your lambda is greater than 30, then you can use normal approximation with your lambda as your mean mu, equivalent to lambda, and your sigma, which is standard deviation, would be square root of n. So that is the conditions for the binomial and Poisson when you want to use the normal approximation. Binomial and Poisson distribution are discrete random variable, and the normal is a continuous random variable. So to use the normal approximation, because it's different, so you need to use correction continuity. Now, let's look at one example if px greater than a. So, correction continuity, whether you need to add 0.5 or minus 0.5. How you want to know is that, try to sketch the real number line. Let's say this is a. Okay? Okay, so this is a. Your a is not included, so it is a whole to your right because it is greater than. Since a doesn't have to be included, so you just, and started from your right will be plus 0.5. So your correction continuity would be having px greater than a plus 0.5. There are more of it, so try to sketch your real number line. Then the last part is you need to solve using the standard normal. Again, standardize using the z-score, where you can find the z value, then find the shaded area, and you can find the probability. Now, let's look at one example. Most of the student, most of my other student from other classes ask this question about the Baraka Bakery where you have raisins and buns. So let's look at the question. So this is a question. So from the question, the bakery claims that the pack of their 10 buns contain average 75 raisin, and a Poisson distribution is used to model the number of raisin in a randomly selected bun. So you can write your random variable as x. So x is the number of raisins. with your lambda here is 75 resin for 10 buns. Okay, so this is what the question gave. But for part A, now let's look at part A. They're asking for probability that a randomly selected buns contain more than 8 resins. So they're asking about probability for part A. X number of resin is more than 8. Now my question, what is the lambda for this question? Lambda here is going to be, because this is a selected bun, so lambda here, instead of 75, because 75 given for 10 buns, so for one bun you need to do 75 divided by 10, where you get 7.5 raisins for a bun. So you can say that X number of resin with lambda 7.5 resins for a bun. Then from here you can solve. Because X greater than 8 for Poisson, you have to use complement rule, where 1 minus by Px less than equivalent to 8. But if you look at your answer, you have to calculate from starting from 0 until 8. Is it practical for you to calculate one by one? Can you question yourself, madam? Can we use the table? Sure can, because if you look at your lambda here is 7.5. Now, if you look at the table, there is lambda 7.5. Alright, so table says that your probability given is for X greater and equivalent to R. So since the question is Px greater than 8, you need to change to greater and equivalent. So this one you can say that Px greater and equivalent to, after 8, your discrete will be 9. So look at the number 9, you're going to have 0.3380. So your answer from the table, Px greater than equivalent to 9 is equivalent to 0.3380. So that's how you answer part A. Now let's look at part B. Part B, find the probability that in a pack of 10 buns, at least 2 buns contain more than 8 resin. Now my question, the question asking about raisins or about buns? So if you look closely, now for part B, they actually asking about the probability of at least 2 buns. So at least 2 buns means that you are talking about buns. So are you gonna be using the same distribution of X? No more. You are gonna use a new distribution where you have to change to new distribution. Name a new unknown, let's say Y, with number of buns. That number of buns, is there any condition of the buns? There is a condition or the criteria of the bun, which says that the bun must have more than 8 resins. So number of bun with more than 8 resins. Okay, now what is the distribution for Y then? Now since this is more than 8 resin, is a criteria, it's more likely it's a success event. Now what is it that you have a success event? Is it a Poisson, or is it a binomial, or is it a normal? Now if you look closely, in a pack of 10 buns over here, it's actually your number of trial, 10. and the criteria more than 8 reasons is your probability. So you can say that your y have a binomial distribution with a trial of 10 bunts, and the probability of success p is actually is the number of resin for a bun, which is you find already, greater than or more than 8, which is your answer just now, 0.3380. So from here, you can answer already the question asking at least 2 buns with more than 8 resin would be py, which is greater and equivalent to 2 at least. So again, you can use the formula for binomial. You find P2 plus P3 plus up until your n trial P10. But again, it will be not practical for you to calculate one by one, because P2, P3, P4, there will be many calculations that you have to do. So what you can do is that use your complement rule. These are the wanted case. So it will be 1 minus by the unwanted case would be P0 and P1. Then substitute into the formula, then choose 0. Your success 0.338 power 0. Then failure would be Q would be 662, because 1 minus by 0.338 would be 0.662 power 10. Plus by 10 choose 1, 0.338 power of 1, 0.662 power 9. Calculate, you're going to get your answer 0.9013. Okay, that is your final answer. Are you guys okay? If you cannot understand, pause your video, rewind a bit, and try to understand. Now let's proceed to part C. Part C, they're asking about the using suitable approximation and find the probability that in a pack of 10 buns, there are more than 80 resins. So because they give you pack of 10 buns, there are more than 80 resins, and they're asking for a probability which is more than 80 resins. So you're gonna have, are you gonna use the distribution for X or your Y? Question. Because they're asking about resins, so it is a X distribution, where this is your number of resins just now. Alright, but your resins now, they're asking for pack in a 10 buns. So in 10 buns, where your lambda, you know already from your question just now, contains 75 resin for 10 buns. So your lambda is 75 resins in 10 buns. Okay. And then P, probability for X more than 80. They're asking that. Now, can you use your formula? You can. It will be 1 minus by, because X is a Poisson with your lambda 75. So Poisson for greater than, you have to use complement rule for Px less than equivalent to 80. Now my question, is it practical for you to calculate 1 by 1 starting from 0, plus by P1, plus by dot until plus by 80? Question? It's not practical for you to use this. Alright, so straight away you say that your lambda is 75, which is much greater than 30. So you can use normal approximation, where your lambda is your mean, gonna be 75, and your standard deviation sigma is square root 75. Okay. Now for Px greater than 80, because it's a Poisson distribution, you want to change to normal. you need to use correction continuity. So correction continuity, whether you add or minus 0.5. So for this one, 80 whole not included to the right because greater than. So not doesn't have to be include 80. Take it from your right, it will be plus 0.5. So it will be correction to 80.5. Then use your Z score to find your Z will be 80.5 minus 75, which is your mean. This one divided by square root 75, your sigma. And you get your Z would be 0.64. Okay. Then find your region. Sketch at 0.4 because greater than. Use the table. The table will be 0.6. 4 will be 0.2611. So final answer 0.2611. So that's how you get your probability for more than 80 resin using normal approximation. Again, the step is that write your first step, write your probability notation. Then second thing, do your correction continuity. Then the third thing, use your standardizing. Then find your Z value. Then the shaded region, the area will give you the probability, which is your final answer. Okay.